joined by Rita and Carmela from Gusto. They're going to be talking about a sweet and sour CRM platform migration, the data engineering journey and the value unlocked. And I think the thing I've been looking forward to the most about that is that sort of cross-functional aspect to it, working out how you deliver commercial value, working within these two different functions. So we're going to be joined by Rita Figueiredo. Rita, if I could ask you to turn your camera on, please. Rita is a data scientist at Gusto and will be kicking off the first half of the session for us. She will then be introducing Carmela Brook from the data engineering side of the business.
Hi, everyone. My name is Rita. Like they've said, I'm a senior data scientist here at Gusto. I've been here for 2 years. And yeah, for those of you who don't know Gusto, maybe you should join more DSF talks, first of all. But basically, just to give you an overview of who we are, what we do, we're basically the UK's best value recipe box. We deliver 8 million meals monthly, but we're only just getting started. We have this vision of becoming the UK's most loved way to eat dinner. And obviously to do that, we need to be super customer centric, and we need to have a way to manage our customer relationships, our interactions with them. So actually the CRM platform that we have to do that needs to support that vision. Which is the story that we're bringing to you today. So we're bringing that sweet and sour CRM platform migration that we had. And Carmela is bringing you the data engineering journey to do that. And then I'll go ahead and talk about the value unlocked for data science. And so just before Carmela goes on and talks about the tale of the Braze migration, just to introduce her a bit, she's a data engineer in our data platform team. This team is responsible for the data journey end to end from ingestion to BI reporting. She's joined us in January, and ever since she's been helping the team ingesting, processing, storing all different types of data from across the business to make it that end users just like me, just like data scientists, can consume this data effectively. So without further ado, Carmela, if you want to take the stand.
Hi everyone. So yeah, I'm going to talk to you a bit about our Braze migration and what the data engineering journey looked like. If you go to the next slide. So we were initially using Salesforce, but the offering that we had didn't provide enough functionality to meet our marketing requirements. It was limited to more traditional channels like email and SMS, and we really needed a mobile-first platform with newer channels like push and in-app. So we knew we had to find a new CRM tool. We selected Braze due to its omni-channel marketing capability. So this is where you can reach customers via multiple channels in an integrated way, preventing the customer from having to essentially start from scratch every time they use a different channel to interact with Gusto. In Braze, this is achieved by the concept of a user profile, and the user is always the center of the marketing campaigns. By also migrating, it did allow us to merge our comms into one platform. So previously, we did actually have a separate platform for some of our transactional comms. If we go to the next slide. So a bit about how the data used to be sent to Salesforce. We used to take SQL codes largely from dashboards and essentially export that data from the data lake in a manual batch process, and then in another manual batch process, upload that directly into Salesforce. Naturally, being manual leads to a high risk of human error, and being a batch process leads to potentially changes to customers or new customers not being captured because you're only capturing them when the batch is run. So we were potentially sending out of date information in our comms. There was obviously a need to migrate to Braze, but there's also a need to automate this process and upgrade it to a real-time stream when we migrate. So if we go to the next slide. So Braze, being an omni-channel marketing platform, it has its user at the center of its campaigns. It has a user profile, and this contains the single customer view about each customer. It has all of the customers' attributes stored on the profile, and this can give a complete picture of their interactions with Gusto. So some of the customer event attributes that we needed to send might be the subscription delivery date or their subscription frequency, for example. We also needed to be able to trigger comms based on custom events occurring. So an example might be if you've reset your password, you need to get an email sent to you with a reset link, or a user has a refer a friend code and that's been used by somebody else to sign up. These aren't really attributes that we need to monitor the state of, and they don't need to be persisted, but we need to be able to trigger comms based on them. And Braze obviously offers this real-time updates via its APIs. So that allows us to move away from the bulk uploads. In order to achieve this diagram, essentially, in Braze, we needed an architecture to be able to support this and send the required events and attributes in real time via the API. So if we go to the next slide. So a little bit of a background on the Gusto architecture. This is a really simplified diagram, but essentially we have an event-driven microservices architecture. It largely consists of AWS Lambda functions, and they consume events from other microservices. Each of the services are decoupled. They're responsible for a particular domain. It might be payments or subscriptions, for example. And there's asynchronous communication between them using an event bus, and that's where messages are published to and subscribed from. So the event bus is a simplification for many different SNS topics and SQS queues. We do also support a legacy system, which is our relational databases. These are not event driven and they have a much higher latency. This architecture, on the other hand, offers real-time data delivery. So we knew that it was essential that this needs to be the data source for Braze in order to achieve that data freshness. And it does contrast the old Salesforce architecture, as where that was pulling from the data lake, that data was originating from the legacy systems. So on top of it being a batch, it also had that inherent latency at source. Moving on to the next slide. So the initial architecture that we had, so we needed to get the data from source to Braze in real time and automated. The initial architecture didn't involve data engineering. It was just software engineering, and it was a minor variation of our existing architecture. We could have a Lambda function that could pull directly from the event bus, all of the attributes and events that we need, and send those to Braze. So the architecture benefits from the real-time delivery and simplicity. It's only adding a Lambda function, and that is required to interact with the Braze API. It's very, very good for the transactional events. So these are the ones that require real-time delivery within seconds. For example, the password reset email, you'd expect to receive that email within seconds. And it's also good for events that don't really require any modeling. They could just be pulled directly from the event bus. Where it does lack is more to do with the attributes. These will require a lot more complicated modeling. The data might not exist in the source data, or it's not in a suitable format. It might have to go through a series of transformations to be able to generate that attribute. And it might need to wait for other messages to generate before it can also be created. So there were some limitations to this design, and that's where data engineering was brought in. So we go to the next slide. So why were we needed? It was mainly for two reasons. First being, we needed more advanced data modeling capabilities. So where we have each of these microservices, they're singly responsible for one domain, and we needed to be able to collate across multiple services. The messages don't always arrive in a useful order, and that is due to the eventual consistency of the architecture. Some of the messages need to wait for other messages to arrive in order to generate the attributes. And we really needed to window across the messages to be able to pull the latest information. So a really good example that we have of maybe more of the advanced use cases for modeling was to do with our future orders. Every time an order is created or cancelled or updated, we need to reprocess again what is the next delivery date and the second next delivery date and so forth. And this information can span multiple different source messages. We need to know the true order that these messages arrive so that we can calculate the latest state for that customer. Those messages also might be duplicated by the other messages. And for some of the attributes, we need to model first attributes. And then if those attributes change, then they generate the new attributes. So as you can imagine, it can become very much more complicated than just pulling the messages from the event bus. The second main area was to do with the charges that we get from Braze. So every time we send a data point by the API, there is a charge. So we really needed to be restrictive about how much data we were sending. And we really just needed to send only the attributes that have changed or any new attributes to ensure the cost efficiency. The previous architecture could have sent inaccurate data just in an append fashion, causing spikes in Braze. And that's because it's not monitoring it wouldn't have monitored what's already been sent. It would have taken the data at that point in time and sent it regardless. So we know that we needed to basically monitor the state of the single customer view prior to sending it to Braze, so that we could, so we know what's already in Braze, we know what the view is now, and then we can calculate exactly what has changed. So for these reasons, we developed a new architecture. So this is a very simplified diagram of our architecture. We ingest messages from the event bus and apply a series of Spark streaming pipelines using Databricks. This is a simplification. What actually happens is the data moves from the event bus through the raw layers and then the cooked layers of our data lake, where they're stored as delta tables. From cooked, we model our attributes using delta streaming, and that creates either our single customer view or our custom events, which are a series of delta tables stored in our served layer. So a quick background on what delta tables are, if you're not aware. Delta is an open source data format created by Databricks, and it basically sits on top of Parquet files and brings data warehousing capabilities like ACID transactions to data lakes. And it allows you to apply certain operations like updates, deletes, and merges to your tables. So going back to the diagram, if we take a look at the custom events pipeline, this is just a simple append only streaming pipeline. We model some custom events because they do just require a bit more complicated modeling. But as the messages are generated, we just model what we care about. We don't need to worry about monitoring the state. We stream that data to the event bus, and that is essentially writing it from our tables to SQS, and then that's sent to Braze. The event bus and the Lambda function are actually owned by software engineering. So this is still very much a cross-functional architecture. The single customer view, on the other hand, is a little more complicated. So we use the delta merge to upsert our data into the tables, and this helps maintain the latest state for the customer. We only want one row per customer. So if the customer doesn't exist, insert the row. If they do exist, update the row with the new attributes. Once it's in the customer view tables, we stream those changes using delta streaming and a really cool feature called change data feed. So change data feed basically records all of the changes that have happened to a table. So you can see a before and after for all of the changed rows alongside all of your inserted rows. From that, we can calculate the exact attribute in the table that has changed by using a Spark extension diff package. And this essentially calculates the differences. So what happens is when we send the data to the event bus, if it's an insert, we send the whole row. If it's an update, we only send the changed attributes. For the single customer view overall, by using the delta merge, we can ensure that accurate, up-to-date information is being sent about the customer, as this is always maintaining the latest state. And by using the change data feed and the diff library, we can ensure that only the delta changes are being sent, so we can minimize our costs. If we go to the next slide. So there were two initial issues we had whilst building out this architecture. First question we had was, what if the data we need doesn't exist in the source messages? The microservices architecture is only a few years old. So from that, we basically supplement some data from the lake. where this data is being originated from the legacy databases. So this just helps bridge the gap until the source messages can be generated in the event architecture. The next question we had was, how do we solve the issue of introducing a new attribute and updating Braze for all of the historical users? We don't want to be sending hundreds of thousands of rows to Braze every time we create a new attribute. So what we do here is actually run a process really similar to the old Salesforce architecture. We run the manual queries on the lake and essentially bulk import that data to Braze to minimize costs. When we then stream the new pipeline, we can apply a filter to it so that only the data going forwards is processed and then all the historical data is ignored. So if we go to the next slide. Another cool part of the architecture that we built out as well is enables us to extract insight from user interactions. So Braze basically stores information about how a customer interacts with campaigns and also Gusto's app. This might be data relating to customer engagement events. So for example, email, when an email is opened, or it might be to do with customer behavior and user events. So for example, when someone starts a session on the app, and what Braze Currents does, it basically pushes this data for us continuously as Avro files to S3. Those files are ingested into the lake via our Spark streaming pipelines and then streamed to DynamoDB. Our customer care agents can then use this data from DynamoDB to in their dashboards and give bespoke customer support. So it's a really good feature with Braze to be able to utilize to ensure that we're always trying to keep our customers happy. And overall, it's great because the currents data and the single customer view together give a really complete picture of our customers. Next slide. So some of the learnings and limitations. One of the big ones was the time sensitivity of switching off our old architecture did result in some compromises having to be made in our new architecture. So one of the areas is our monitoring solution is limited to just our pipeline failures only, and we really want to be expanding that out to get visibility over how much data we send, when data is not updating, the impacts of failures and stuff like that. There were a lot of change in requirements, and that did slow the team down. Some of the attributes can be modeled in lots of different ways. So sometimes the accuracy had to be sacrificed for a quicker time to release. And that also went hand in hand with having a limited time for testing as well. The process for being able to support incidents isn't clearly defined. It's our first use case, providing data to an operational system. So there's a lot of questions to ask, how do we support a critical customer facing system like this? It's very different to the support that we would give for consumers of our data lake. And also our backfill process is still quite manual and ad hoc. There were also challenges with sourcing the data in the first place, trying to find the data, understand what it means. It required quite a lot of communication with multiple different squads. With the microservices architecture, it can lead to differing schemas across messages and also sudden schema changes. And finally, it was quite difficult to understand how a user's interaction with Gusto can generate events, and then also to be able to test that. So yeah, despite some of the challenges, one area which has really benefited this architecture is data science. Next slide, sorry. So basically, this is the architecture of how we can basically integrate our data science predictions to Braze quite easily. Data scientists can now write their predictions straight to the lake, and we can simply ingest them into our existing architecture, into our single customer view, and send this to Braze alongside all of our other attributes. So without this streaming architecture, data would have to be manually uploaded to Braze as CSVs. One of the predictions we do send is to Braze is the offer optimization. So I will pass you on to Rita to give some more detail about that.
Hello again. Let me exactly everything working again. Okay, so yeah, as Carmela was saying, one of the products that is actually using this pipeline that data engineering built is offer optimization. First of all, just to give you a bit of background on why we thought we needed this offer optimization product. Basically, we knew we had such a diverse customer base, and static offers wouldn't allow us to choose the most relevant one for each customer. So we knew we had customers like Lydia, who's very engaged with the app, but doesn't open emails at all and loves premium recipes. And we also knew that we had customers like Adam, that on the other hand, always reads his emails, but never downloaded the app, and is very conscious about his environmental impact. So that is why we decided to work on offer optimization. And just the first thing to clarify is that offer optimization isn't a standalone model. It is actually a product that consists of a lot of different models. And the reason that we have this is because we have these different marketing contexts, these different marketing campaigns, and we optimize for each one of them. So model one, the blue one could be serving one of the marketing campaigns whose objective is to bring back customers that have paused their subscription. As you know, like Gusto is a subscription-based business, so one of the marketing campaigns that we have is to bring back customers that have paused their subscription, and the model one could be being the objective of that model could be that, and the action could be giving personalized discounts, whereas a model two has the objective of increasing brand love, and the action could be like sending personalized treats. And the one that I'm going to be talking to you about today is the pause prevention model. So this has the objective of preventing users from pausing, and the action that we give is to give personalized discounts. So pause prevention, as the name suggests, gives personalized discounts, and in the pause prevention journey. And what is this about of the pause prevention journey? So basically, if you go either on web or on app to your subscription settings, and you click on that pause subscription button, what happens is that a pop-up comes and tells you, look, we have this discount to you. Do you still want to keep pausing? And the user can keep their subscription with the discounts or pause anyway. And what we're optimizing is that number there that we show the discount on this specific model. And first of all, I'm going to explain what this model does end to end. And the first cool thing about the model is that we have a full experimental approach. And this starts with collecting our training data. So we collect our training data in an experimental fashion, and then we go ahead, develop our model and A/B test it. So it's full on experimental. We have that causality loop from one end to the other. Collecting the training data through an experiment. How does this work? We basically give random discounts. So user C could be getting 20% discount for 3 weeks, whereas user A could be getting 25% for 2 weeks. And then we check if user A paused anyway and user C kept their subscription. So this is how we collect our data. Then I would like us to take a slight detour on before explaining how the model works to a casino. This is a very simplified way of explaining so that it could fit this presentation. Basically, you have to put on the chat whether you'd bet on whether you'd choose the dice or the coin, knowing that if you rolled a 6 on the dice, you'd win £150. If the coin lands on heads, you win £60. So which one would you choose? Dice or coin? I can actually see the chat. Okay, cool. Yay. Lots of good answers. So let's say that everyone is correct. Yes. I'm glad that the example was pretty fast. So yeah, you choose the coin because it maximizes your win, right? So this is exactly how our model works as well. So there are 2 steps in the pros prevention model. Step 1, we calculate the probability of retention at a given discount. So for each customer, we have the probability of retaining for each of the discounts that we offer. And that gives us the probability of retention. On step 2, we calculate the average order value for the users that were in the 20% discount, and then for users that were in the 25% discount, and then for the ones that were in the 30% discount. And the offer that we're going to choose per customer is the one that maximizes the probability of retention times the average order value, just like you chose the coin, right? So this is how our model works. And then another really cool thing is how we make this work with this the amount of models that we have, and we need to access these features for training, for inference, and there are different features that we need for different models, right? Because we're optimizing for different things in the different marketing campaigns. And how we achieve these is actually using feature store. So they are really good for us because we have, as I was saying, a separate algorithm for each type of use case. Each use case has different features that they access, so we don't have to recompute every feature, and also gives us some consistency between our model training and inference, which in the end will lead to better model accuracy. It will eliminate some skews, and yeah, we have this shareable and reusable feature across our models that we can use for either training or inference. And yeah, so using feature stores was a really milestone for us because it allowed us to have all these different models. Then okay, we have our model, we get our results, and we look at those ROC curves, and oh no, they don't look good. What are we going to do? And the message here is, don't let a poor ROC curve discourage you from all the model impact all the business impact that you can have. Because when we started looking at it, so at first we were really discouraged with the ROC curve, and then we started looking at it in the middle plot. We actually plotted the estimated retention probability means, the ones that we calculated, with the actual retention rate. And what we could see is that our model is actually onto something. It could actually predict whether the customer would retain. And when we actually A/B tested it, then after being discouraged, then we went through that downhill of emotions. And then when we actually A/B tested it, what we could see is that in the business context, we were actually able to give a lot less discounts for the same level of retention, which obviously is pretty impactful. And now, how this all ties in with what Carmela explained on the data engineering side is that basically for us, our deployment was massively improved by having Braze pipelines. So basically we have this pause prevention model that is trained. There's a train service that outputs this pause prevention model. Then there is an inference service that gets that uses a pause prevention model to then have the offer per customer. And how we do it is we have this batch process that writes the offers per customer to the single customer view to the lake, and then using the data streaming pipeline and the event bus that Carmela explained there. What happens in Braze is that a field is added to the customer profile. So you have these new fields on the single customer view on Braze that tells us which offer we want to give for each customer. And then on our marketing campaigns, if that field is present, then we're going to send that offer to that customer. So as Carmela was saying, massive improvement for manual uploading of CSVs, as you can imagine. And yeah, finally, just to wrap up with Lydia and Adam as well. So this CRM platform migration allowed us way more personalization because we have this single customer view. So if we know already, we have that model that says that Lydia would actually rather have an offer, which is a premium recipe. And we know we can communicate with her via in-app messages, which Braze also allows. Then we're going to do that, offer her that premium recipe and communicate with her via in-app messages. Whereas Adam would prefer to have seeds to grow aromatic plants sent to him and communicated via email, because we know he's never really engaged with the app. And I think, yes, that's it from us, from our presentation. And I believe now it's on to questions.
I'm coming back. I'm back. I had that awkward moment where I couldn't quite find my mouse. So yeah, I've made it happen. We've already had a little clapping emoji in the chat, which is always a good sign. So yeah, there was lots of people watching along answering your coin question. So yeah, if we can have a few more comments in the chat, it's always really nice just to let the speakers know that there is people watching along at home and around the world. So what I might get you to do is just stop sharing your screen, and then they'll be able to see our faces a bit bigger, which I know everyone at home will obviously appreciate as well. I will jump quickly into the chat. There's already a few questions in the Q&A. I've got a couple myself, so if you do have any more questions, please do put them in the Q&A. And while those are coming in, I'm going to do my best to fire through some of these. So Daniel Ball, Andrew Murphy, Michael, Zahid, all clapping and fire emojis. Do we have an opinion on emojis? Do you put an emoji in an email? Just me? No?
I'm all
Carmela,
for.
I've got to grab something out of you. Either of you, who puts an emoji in an email? Is it a good thing or bad?
What do you mean, in the body of the email?
Yeah, like if you're sending an email. Yeah, good. Carmela?
I'm a fan.
Yeah, good. We were having a chat in the office and we're 50-50 in my office. So it's nice to see that we've got the emojis here. Froya, good to see you. I did see you get that question right as well, Froya. So very, very well done there. Ali, Elena, Ellie, Joe, Ellie, Ghazal, Zahid, really appreciate the talk. Thank you both for your time. Thanks, Carmela and Rita. That was really good. Great presentation. Very interesting. Louise Kirkham, good to see you. Thanks, Rita and Carmela. Good. Do not tell anything is acceptable, blah, blah, blah. Emojis, yes. So this is people commenting on the emojis question. We're getting a mix of emojis opinions, but emojis, yes, is the overall thing. So we'll get into the Q&A now. I'll maybe kick off, actually. I'll come to you first, Carmela, in terms of the architecture. And one thing is probably a little bit of a hot topic at the moment, but how does your architecture handle personally identifiable data? Is that something that you've thought about in how you've designed this system?
Yeah, so actually, where this architecture isn't actually used for anything else in the lake, so by design, we wanted a latency of 1 minute, so we created another event bus, and that data, all the Braze data from raw onwards, isn't being used by anybody else. So like, as a positive consequence of doing that, it actually meant that we didn't even have to worry about the PII data, because we could lock everything down and only give permissions to the jobs that are running. And what we have instead is all of the events that we're ingesting from our microservices. They are also ingested in parallel with a higher latency, and that goes through the data lake, and that data in parallel is being consumed by end users. So that's where we have to care about the PII. And for that and the rest of the lake, we have anonymization. But yeah, it was quite good for Braze that we had to we could just lock everything down.
Worked well.
Yeah.
I love it. I'm going to keep coming with you, actually, Carmela, for 1 second. I'll come to you in a second, Rita. There's definitely a good few questions coming in for you as well. But we'll kick off with the engineering side, and then we'll flick over a bit for the data science. You can read along at the same time, Carmela, in the Q&A. There's a question at the very top there from Ankit, which I thought would be quite a good one to start off with. So Ankit says, hey, Carmela, how are data quality issues in Braze handled in your current architecture? So what does it look like from the data quality perspective?
So I guess when we have data quality issues, what will typically happen is we might get marketing say that, this attribute's not looking right. We would then investigate, is it something wrong with the way that we've modeled it? So we'll, start in the service layer. Is anything gone wrong there? No. Move further upstream, check if anything's gone wrong in, our cook layers, our raw layers. And And, you know, if it is a case of everything is right on our end, then it might be a case of raising, you know, that issue further upstream with the owners of the data source. But typically it might just, it usually would be something that we can fix. And again, kind of going back to the point of like the time sensitivity that we had with the project, there are instances where this does happen because of we didn't have, you know, as much time as we wanted to be able to test the modeling that we were doing.
Amazing, thank you very much. I think it's very clear that this has been a team sport to get this to work, and I've actually got a couple of questions about how that's looked as well, but thank you for that one. In terms of the next question, let me go to Paolo. There's a question there for you. I would guess Rita may be the best one, but obviously Carmela, jump in if you think so. So Paolo, good to see you. It's a shame it's not in person, but yeah, good to see you online. Paolo says very nice presentation. How do you retrieve data on users' attributes? Is this something that the users tell you explicitly, or do you infer it from somewhere else? So I guess obviously you had two very clear users in your presentation there. How did you kind of clarify, you know, what their preferences were?
So yeah, a bit of both, I would say. So there is something that some bits on the sign up journey that the users do tell us. So we have those because the user gave us. And then there is a bit of feature engineering, based on, for example, complaints data, where we can retrieve things that the customers like and don't like, or just based on, the order history. Obviously, you can see if a person has ordered premium recipes or not. So yeah, a bit of both.
Amazing, thank you very much. I'll follow on actually with the question from Daniel Bull, and this is probably something that can take an input from both of you. And it's very much about how you work together to achieve this kind of shared goal. So Daniel Bull says, hi Carmela and Rita, thanks for the great talk. What kind of process did you use to align the data science team's requirements with the utility being built? Were there any specific challenges? So I'll maybe come to you first, Rita, and then maybe get you to jump in as well, Carmela, if you have anything to add.
So I think with data engineering, we are basically their stakeholders, right? So every big project that they work on, we're going to be aligning what we need. And it's not just the CRM platform, it's everything that they, like the data lake that we're using every day. So we're extensively using Databricks, we're extensively using DBT, all because it's capabilities that they've brought for us as a data platform team so that we could use on a daily basis. And yeah, it's come with its challenges. We've had to introduce a lot of job pins for them to be able to tell us how we could do specific things. But yeah, I don't know, Carmela, if you want to input on how the challenges look like from your side.
So I'm quite new to this project, so I don't have too much like history, like knowledge, I suppose, of how the interactions kind of worked with everyone. But there are quite a lot of teams involved. You know, there's software engineering, there's the data engineers, there's data science, there's marketing, and then we also have, you know, data analysts that can help us try and source some of the modeling queries behind the attributes. There are a lot of people, and we have kind of streamlined now, I think, our process of, you know, how we deal with like ongoing requests and things like that. But, you know, at the moment, it has just been very collaborative of everyone is kind of on the same, you know, Slack channel. Everyone's kind of, you know, messaging and helping each other along the way.
Amazing. Yeah. Thank you both very much. I guess one final question from that on me is, I'm guessing it also leads out to, you know, sort of marketing and comms teams, and you've kind of run your model, you have, you know, change an attribute in the CRM, and then that triggers some communications through an automation through Braze. What was that final step of creating the offers and building those comms? Was that a different team, or did the data scientists come up with the offers as well?
I don't know, yeah, different. So definitely with the team, with the marketing team, yeah.
Mm.
So there's a lot of collaboration as well with the marketing team. We work quite closely. So they're the ones who we talk with to know what offers we're going to send in that to collect data for training, basically. So yeah, they are the ones we have to liaise with to know what we can and what we do offer.
Amazing. Thank you very much. Talking there about training, you did mention that you had, sort of experimental data collection. How does the retraining work when the data is collected and, it's out of date or anything like that? How does that process work?
Yeah, of course. So basically what we have right now is that we have 10% of the flow in that page that I showed where you go and don't click pause. But we have 10% of the flow going to random discount assignments instead of going to our model. And that is how we have the random training data keeping to retrain our algorithms.
Amazing. Thank you very much. I think we'll go with, I'll give you a heads up actually, Carmela. I'll do Ellie's question with Rita first, and then after that we'll come for Giselle's question. Hopefully I pronounced that wrong. I'm really sorry if I haven't, which is a bit more engineering focused. So we'll come to you first, Rita, talking about, the question is from Ellie. Hi Rita, are your probabilities calibrated?
Yeah, really quick one to answer. The answer is yes, they are. I guess I could also answer Zahid's because it will help on the pipeline to answer Ellie as well, because so clarifying how we do it. So we have this training data where we offer customers different discounts. And what we do is we have a binary classifier with that training data, and then we use that binary classifier, which is calibrated as per Ellie's question. And we apply that classifier to each of our customers, and if we offer this discount, what would be the probability of having keep or pause anyway. Basically.
You're even communicating in emojis on the webinar. Thumbs up. It was a thumbs up. So I was trying to buy a bit of time there, Carmela, to get your head around that, and I thought we were just going to get a one-word answer, but we've proed it out with Rita. So I will come to that next question, which is very much focused for yourself. So it's actually a couple of questions in one. How is DynamoDB performance with dashboard? Do you know what? I'll maybe go through them one at a time, actually. So in terms of DynamoDB performance, is that something that you were aware of or have looked at?
That isn't something I'm aware of, because the DynamoDB table is actually owned by the software engineering team. So that kind of integration with customer care isn't something I know too much about. But yeah, I mean, feel free to, reach out on my LinkedIn or something, and I can try and find out from internal teams.
Giving yourself a bit of homework there. Honestly, you've only signed up for a lunchtime session and now you've got homework. Next question, talking about the historical backfill of data and that process. How is that running? Is it checked manually? Can you tell us a bit more about, what you're planning to do there?
Yeah, it's still very manual. It's kind of ad hoc at the moment. It's typically when we have a new attribute that we want to send, that we want in Braze, and we've got obviously all this historical data. We do not want to be processing that and sending that. So it's kind of as and when we need to, that we do this historical backfill. So I guess that's why there hasn't been too much of an incentive to, automate that or make this more efficient or anything, because we've not had to do it too often. So yeah, that's not something at the moment we've got when we're too sure of what we want to do next with it, basically.
Amazing, thank you very much. I seem to be timing you answering your questions with having water in my mouth as well, so I need to become a bit more pro at this, I think. So there's a couple of questions actually. It's Giselle's last question about Databricks, but I did also see one down there from Louise Kirkham as well, and they kind of bleed together a little bit. So the question, generally speaking, is why was Databricks chosen over AWS governed tables? And Louise kind of again builds on that. She was wondering why choose Databricks over the cloud providers sort of proprietary technology, native technologies, or whatever. So
Yeah, so yeah, Databricks is our tool of choice anyway within our data platform. And that is a lot to do with the fact that Databricks offers the lakehouse architecture. So, we can merge the kind of data warehousing capabilities and all the benefits of having a data lake together as a lakehouse. And they give you, that web UI where you can have a workspace and interact with Spark in lots of different ways, with a notebook or SQL interface or running jobs, and everything they do is kind of centered around Delta, which was very crucial for this architecture because we really we needed to use the functionality of a Delta merge to be able to kind of maintain that latest state of the single customer view.
Awesome. Thank you very much, Carmela. There's a few questions still to get through. I'm a little bit conscious of time, but I think we're still good for now. So I'll jump to the question that's come in from Kate. Kate says, thank you for a great presentation. Super interesting. My question is, were data engineering stakeholders involved in the upfront decision-making process to move to Braze? So I'm going to guess no, but let's see.
Yeah, I don't think data engineering was involved because we were brought onto the project whilst it was already happening. So yeah, I think that would have been a marketing decision.
Amazing. Sounds good. Thank you very much. And then I'll take these last couple of questions in order, and I've still got one or two of myself, so I'm keen to keep that going. So question from Stefan. Stefan says, thank you. Does the feature store read from the latest data in Braze / the event bus, and can it use changes in events to trigger model runs?
So at the moment, actually, we're not. Oh, sorry. At the moment, feature store has features from the data lake, but it's not reading from Braze yet. But yeah, that is true. That it is one of the things that we have in the roadmap to add to our feature store, because it is something that we can do now quite easily, whereas before we couldn't. What was there was another part of the question, wasn't it?
Bear with me. I'd already clicked on answered. I was a bit too keen. So there is an answered section there. So Stefan's question, does the feature store read from the latest data in Braze / the events bus, and can it use changes in events to trigger model runs?
If the feature store can use changes and events to trigger model runs, not sure what we have is a scheduled job right now, because we want to have the outputs for specific marketing campaigns that are on a specific time. So it works in a scheduled way. So not sure if it can be. It's not the way we're using it, at least.
Okay. That actually, you talked about there a bit about the roadmap. That was one of the questions I'd written down. You've obviously, built something very good to this point in time, and you've been up against time constraints, and you've delivered the commercial value and all that sort of stuff. What next? What is it that you've got on the roadmap? What would you like to achieve in the next sort of 6 months or so?
There's a world of possibilities. Basically, because we're involved with the marketing team, there's always this marketing campaign that we're still not. So we're very close with the retention team, but we're still not putting this output into the acquisition space, for example. Or there's also some feature improvements that we want to do, and so every time that we're going on a new marketing campaign and changing slightly the algorithm to work for that campaign, what we'll do is put those model improvements. They could be in the form of new features from Braze, for example, or other things, and they will put them into that model and test that new feature as well. So yeah.
Amazing. And Carmela, from the engineering side, you touched a bit on monitoring and stuff like that. Is that what are your plans?
Yeah, so we've still got a few more attributes that we want to model into Braze. There's a lot of engineering improvements that we want to make to our platform. And yeah, the big one is monitoring. We really want to get better visibility about what is impacted when things go wrong, and to also kind of preempt when things are going to go wrong, to be honest. So that's the next immediate kind of piece of work is definitely going to be the monitoring.
Amazing. Thank you very much. I'm going to ask the question. I'm not sure if you'll be able to answer it or not, but I'm guessing the move from Salesforce to a new CRM, there were specific commercial aims from doing that, more targeted monitoring, covering more platforms, etc. Have you been able to assess the commercial success of the work that you've done? Are you able to tell us how it's impacted the business?
That is something I actually wouldn't know how to answer. Yeah, so again, I think that's going to have to be something that I take away, because I'm not, unless Rita, you know anything about it. But yeah, I don't know.
No.
Sorry, I had a feeling. I can't stop myself from asking these money questions. I'm just obsessed with money. What's going on? Cool. There is one final question in the Q&A from Michelle, which we'll take now, and then we'll draw things to a little bit of a close. So the question there is, how can you be sure that the % discount was the driving factor while training, as opposed to the length of the offer, whether it was 1 week, 3 weeks, etc.? So is there anything you can tell us on that, Rita?
So basically what we call the offer is not only the percentage discount, is percentage discount with the length. So that is the offer that we're optimizing. How we can be sure, we A/B test everything that we do, and when we A/B test, we see that, okay, some people prefer the 30% only for 1 week, but some people would react better to a 20% discount if it lasts for longer. So yeah, we A/B test everything. I guess it's the answer on how we are sure what is driving the pausing or not pausing.
That is the correct answer as well. We've answered with we finished with a big success there. So I will draw things to a little bit of a close there. I'm going to wrap up by saying thank you to Gusto. As I mentioned at the start, Gusto are a big supporter of the Data Science Festival. We definitely can't do it without companies like Gusto supporting us. I definitely want to thank you both, Rita and Carmela. It's not just the turning up for an hour to give the presentation. I know you'll have worked on this in advance and put time into it and a lot of thought into it. So really appreciate you taking the time to come and share with the community. And obviously, as you saw in the chat there was a lot of people out there very thankful for you doing that. So is there any final words from either of you before we turn things off?
I want to hear you say my last name again.
Figueiredo. Is that right? Am I doing it right?
It's perfect. I mean, I say Figueiredo, but
okay.
I like yours better. I might adapt it.
I thought I was doing so well. Perfect. Any final requests from you, Carmela? Do you want me to sing a song or something?
No, all good. Just thank you for having us on to be able to speak about it.
Amazing. Hopefully we get to do something in person at some point as well. The online stuff is absolutely brilliant, but we are still trying to get back in person now and again. So yeah, hopefully we get the chance to do something with you both in person as well. But yeah, thank you very much to both of you. Thank you, Gusto. Thank you to the events team behind that making this all run smoothly. And thank you to everyone at home for joining us today. We will see you all very soon.